Hello everyone, welcome to the discussions of the past year questions. This video we shall take a look at the further mechanic, May-June 2021, paper 33. Let's take a look at the first questions. A uniform lamina ABCD consists of two isosceles triangles ABD and BCD. Okay, so this is a isosceles triangle. Here's another one. Okay, so you have two isosceles triangle here combined together. The diagonal of ABCD meets at the point O. Okay, they meet at the point O. The length of AO is 3A. The length of OC is 6A. And the length of BD is a 16A. So that means this is half A. This is also half A. So these are the information given. Okay, so the questions want you to find the distance of the center of the mass of the lamina from the DB, from the vertical line, DB. So first of all, we build the table. Okay. We can separate this into two isosceles triangle in this way, or you can also separate them into the triangle like this. Okay, then just to find the center of the mass for both triangle and then combine together later on. Okay, so in order to do it, usually for me, usually I will find the coordinate. I will let this as the origin, the O as origin. Then this coordinate will be 6A, 0. This coordinate will be 0, 8A. This coordinate will be 0, negative 8A. And this coordinate will be negative 3A, 0. Okay. Then for me, I will consider the triangle ADC. I will consider this triangle. Okay, I will consider the triangle ADC. Okay. That means I consider this triangle. I consider this triangle and consider the triangle like this separately. I consider them separately. Okay. Okay, so if I consider the triangle ADC and ABC, so I have the lamina. I have ADC and I have ABC. So combined together, I have ABCD. Since they are same material, we're just using the area will do. So the area is half times the base times the height. So the base is 9A, height is 8A. So total will be half times the base times the height. So you have a 36A squared. Same area here because they are same size. 36A squared. Join together, you will have 72A squared. Now we want to find the center of the mass from DB. So if you find the center of the mass from DB, that means you are looking for the bar X. Okay, you're looking for the bar X, the X coordinate. The X coordinate. So for the ADC, just look at the X coordinate. Add together, divide by 3. So add all together, divide by 3, you get 3A divided 3, you get an A. Same thing happened for the lower triangle ABC. You also use the X coordinate, add together, divide by 3, you also have A. Then just take the moment about DB. Oops, I forgot to write DB here. Then you have a 36A square multiply A plus the 36A square multiply A is equal to the 72a squared bar x. Simplify it, you get bar x is equal to a. That will be the answer for the question number 1. Just like that, done. Okay, now we move on. Question number 2. .8 meter and the modulus of elasticity of 36 Newton is attached to a fixed point O on a smooth plane. The plane is smooth. The plane is inclined at the angle alpha to the horizontal, where the sine alpha is equal to the 3/5. The particles of P, mass 2 kg, is attached to the other end of the string. The string lie along the line of the greater slope of the plane with the plane below the level of O. Okay. The particle is projected with a speed of square root 2 meter per second directly down the plane from the positions where OP equal to the natural length. Okay, find the maximum extensions of the string. Find the maximum extension of the string during the subsequent motion. Okay. So over here, you have an inclined plane. This is the alpha. This is the O. Okay. So the length over here is 0.8. Okay. Then you projected down with your u equal to the sub2, and then come to the maximum extension. That means your v will be a 0. Okay, then we need to find the extension over here, x. Okay, so first of all, if we can take the x here, this is the height, this is the alpha. We know that the h over x is a sine alpha. So your h is a x sine alpha. Since alpha given is a 3/5, so your h is 3/5x. You need this because we need to use conservations of energy. Okay, so conservations of energy, you have the GPE loss equals to the KE gain plus the EPE loss, EPE gain. EPE gain. GPE loss is mgh. KE gain is a half m. V square minus a u square. Your oh no, sorry. My EPE, KE is loss. KE is loss. I make a mistake. KE is loss. So by right, I supposed to write like this. Then this is cannot be v square minus u square. It will be a u square minus a v square. Okay, so this one is KE loss, not KE gain. By right, the relationship is supposed to be like that. The KE loss plus the GPE loss is equal to the EPE gain. EPE will be lambda over 2L. Your extension, x square minus a 0 square. Okay, because you start from the original length, natural length. Okay, so this is what we have. So your m is a 2, g is a 10, h, as I've stated earlier, this one is a 3/5x. Your m is a 2. Then your u square is a 2 minus a 0. Lambda is a 36. Your L is a 0.8. You do not know the x square. So now over here, if you simplify everything by using your calculator, you get this one as a 12x plus 2 is equal to the 45/2x squared. So you can see that we are having a quadratic equations over here. Make it become 45x squared minus a 24x plus minus a 4 equal to 0. So the rest will be very straightforward. Try to factorize it. Or you can use calculator to find the roots. So your x is equal to negative 2 over 15. Your x is equal to 2 over 3. Obviously, the value of negative need to be ignored. Okay? Therefore, your answer for x will be 2 over 3. That's all. That will be the answer for the question number 2. Okay. And we move on to question number 3. Particles A and B of masses 3m and m respectively are connected by a line inextensible string of the length A that passes through the fixed point smooth ring R. The particle B hangs in equilibrium vertically below the ring. Particle A moves in a horizontal circle on a smooth horizontal surface with a speed of 2 over 5 sub GA. The angle between AR and BR is theta. The normal reaction between A and the surface is 12 over 5 mg. Okay, so over here, we will start from the B. If you consider the B only hang vertically, so just only have vertical force. So the vertical force at B will be the tension equal to the weight of the particle B. That means the D is here, then the weight is mg. So therefore, you get D equal to mg. And as for the particle A, you have a tension here. And this angle is theta. And you have another normal reaction force. The normal reaction force is 12 over 5 mg. And you have the weights over here is 3 mg. Okay, so this is what we have. So at A, if you resolve the forces vertically, you get T cos theta plus the 12 over 5 mg equal to the weight 3 mg. So if you substitute the value of T equal to mg inside these equations, then you will get mg cos theta equals to the 3 over 5 mg. So therefore, you cancel the mg, your cos theta is a 3 over 5. Done for the part A. And now you move on to the part B. If you move on to the part B, they want you to find in terms of A the distance of B below the ring. That means we are looking for the length of the BR in terms of A. Okay, so for these questions, we will consider the horizontal circular motion, horizontal force at A. So at A, if you resolve the forces based on the diagram, you have a D sine theta equals to the 3mv squared over the R. Okay, so what is the R? Okay, this one I think we cannot solve this one yet. We need to find out what is the R and what is the sine theta first. Okay, so based on the diagram over here, you can see that based on the diagram over here, this is the R, this is the radius. Okay, so the radius, if you consider this as a triangle, if you consider the whole triangle here, this triangle, then you have the R over AR is a sine theta. Okay, so from the triangle, we have R over the AR is equal to the sine theta. Then you're having R is equal to the AR sine theta. But from the part A, we know that the cos theta is 3 over 5. Based on this, we can build a small right angle triangle. Then we know that this is going to be a 4 over 5 AR. Yeah, R is equal to the 4 over 5 AR. Okay, so now we only resolve the forces horizontally at A. So you have T sine theta is equal to the 3mv squared over the R. Okay, so your T already know is mg from the part A. Sine theta we know is a 4 over 5. 3m, just write 3m. Your v squared is a 2 over 5 square root of GA square divided by the AR sine theta. Okay, so if you square them, you will get this one as a 16 over 25 AR mg equals to the 12 over 25 mga. Cancel the mg. Okay, then your AR will be 12 over 16, or you can write this one as a 3 over 4. I forgot the A. AR is a 3 over 4A, but we're looking for BR. We know that the AR plus the BR must equal to the length of the string, which is A. The string is inextensible, so therefore my BR will be equals to the 1 over 4A. Just like that, that will be the answer for the part B. Okay, so now we move on. We have question number 4. Okay. Okay, let's take a look at question number 4. A particle of mass m is attached to one end of a light inextensible string of the length A. The other end of the string is attached to a fixed point O. The particle is initially held with the string tucked at the point A, where OA makes an angle theta with a downward vertical through O. The particle is then projected with a speed u perpendicular to OA and begin to move upward in part of a vertical circle. The string goes slack when the particle is at B, where AOB is a right angle. The speed of the particle when it is at B is half u. See the diagram. Find the tension in the string at A. Okay, so this is the tension in the string at A. I call it this one dA. Okay, giving your answer in terms of M and G. Okay, so this one over here is vertical circular motion. So we will usually I will start from the conservations of energy, COE. So COE over here we have a GPE gain equal to the KE loss. So you have a NGH equal to the half M of the U square minus the V square. So you have a V square equal to the U square minus a 2GH. Your V is actually a half U. Your U is still a U. Your G is a G. Your H is A cos theta plus A sine theta. Okay, because your H, this will be considered as your H. The whole thing here as your H. H is over here. So this part is actually A cos theta. This part is actually A sine theta. Okay, why? Because this one is a theta, that means this one is a theta. Okay, so that is the meaning, or that is the reason why you get H as A cos theta plus A sine theta. Okay, so now we simplify it. We can get this as the 2GA cos theta plus sine theta is equals to the 3 over 4 U square. Okay. Then over here we can have the U square is equals to the 8 over 3 GA cos theta plus sine theta. Okay, I think we just leave it at the moment. Then after that, we want to consider the tension at A and tension at B. Tension at A. Okay, forces at A lah. Okay, that means we just write at A. We resolve the forces. If we resolve the forces towards the center of the circle, okay, if we resolve the forces towards the center of the circle, you will have TA minus the mg cos theta equals to the mu square over the A. Okay, so your TA will be equals to the mu square over A minus the m plus the mg cos theta. Okay, so if you replace it inside, okay, this is a 1, this is a 2. So 1 into 2. One into 2, then you will get this as the TA m over a multiplied by 3 x over 3. GA cos theta plus sin theta plus mg cos theta. So if you expand and simplify, you can factorize the mg out, then you get 11 over 3 cos theta plus x over 3 sine theta. So the TA, we can just leave it over here at the moment. Then now we go for the B. At B, you have the TB plus the mg sine theta equals to the mv squared over the A. So over here is because at B, this is the B. This is your mg. This is your tension at B. This is the theta. Okay. So you will have, that's why you have a dB plus mg sine theta equal to the mv squared over A. So given the dB is a 0 because they say it's slack. So 0 equals to the equals plus the mg sine theta. Is equals to the mv squared. V squared is actually a half u squared. Half u. A. So you get the u square is equals to the 4 GA sine theta. Okay, that will be my equations number 3. Then you just put 1 equal to 3 because the number 1 we have the u square as well, equation number 1. So x over 3 GA cos theta plus sine theta is equal to the 4 GA sine theta. Cancel the GA. Then this is also cancel. So you have 2 cos theta plus 2 sine theta equals to the 3 sine theta. Then you have the sine theta equals to the 2 cos theta. You get tangent theta is a 2. So tangent theta is a 2. From here to 1 square root of 5. Okay. And therefore your tension at A, we just need to replace it inside here. Then you can find the mg. So mg 11 over 3 cos theta. Cos theta is a 1 over sine 5 plus the x over 3 2 over sine 5. So 11 plus 16. 11 plus 16, 27. So you get 27 over 3 sine 5 mg. Right? 16, 1. Okay. So that will be the answer for the question number 4. Okay. So now we are moving to the number 5. Okay, now we take a look at question number 5. A particle P of mass m is projected vertically upward from a point O with a speed 20 meters per second and move under gravity. there is a resistive force of the magnitude 2 MV Newton, where V is the speed of the P at time t after the projections. Find an expressions of V in terms of t while P is moving upward. So while P is moving upward, you are having the negative mg, okay, with the 2 mv is equal to the ma. Then you can cancel all the m, then you get this. Then over here, they didn't mention that they want the answer in terms of g, so I think we can change the g become 10. There's a negative g here. So this one will be a negative 10 minus a 2v. Since they want the v and t, so this will be a dv dt. So your dv dt, it will be, I bring the negative 2 out. So this one, it will be 5 plus the v. And if you integrate it, it will be ln of a modulus 5 plus v equal to negative 2t plus a c. When the t is equal to 0, okay, they say that your v is a 20. So it will be ln of 25 is equal to the 0 plus c. So the c is a ln of 25. Replace it back, you get ln of modulus 5 plus v is equal to the negative 2t plus the ln of 25. Then if you join them together, you get ln of modulus 5 plus v over 25 is equal to the negative 2t. Then you have 5 plus v over 25 is equal to e to the power negative 2t. So when you take away the modulus, you have two choices. Either is a positive e power negative 2t or negative e power negative 2t. In order to fulfill this condition, then you need to choose positive e power negative 2t. Okay, so we just choose positive e power negative 2t. Okay, so your direct choose will do. Then your v will be the 25 e power negative 2t minus a 5. Okay, just like that. Then the displacement of P from x at time t second. Find an expressions for x in terms of P while P is moving upward. Okay, so while P is moving upward, we want to find x in terms of T. So just from the answer here, just copy down, make it become the V, make it become the x dt. So you have the x is equal to integrate this. Then you get this as a negative 25 minus a 5t plus the d. Then when the t equal to 0, your x is equal to 0. So you have a 0 equal to negative 25 over 2 plus d. There you have that the d is a 25 over 2. So from here, you can get your x as the negative 25 over 2 e power negative 2t minus a 5t plus the 25 over 2. Then after that, we want to find, for question C, we want to find correct the three significant figure the greatest height above O reached by P. So to reach to the greatest height, your V must be a 0. Okay, to reach to the greatest height, your V must be a 0. So if your V is a 0 from these equations over here again, so V equal to 0, you get the 0 equal to 25 e power negative 2t minus a 5. Then you get the t is equals to the negative half ln of 1 over 5. Or you can say half ln 5. Okay, Then when t equals to the half ln 5, what is your x? Your x will be negative 25 over 2 e power negative 2t. Negative 2t, it will be negative ln 5. Then minus 5 of half ln 5 plus the 25 over 2. So we just need to use our calculator. This one, it will be negative 5 over 2 minus the 5 over 2 ln 5 plus the 25 over 2. So we press the calculator, you get 2.5 multiply ln 5, then plus the 10, 5.98 meter. That's all. So that is the answer for the question number 4C. And that's it. We are moving to number 5 and number 6. Now we take a look at question number 6. Two uniform smooth sphere A and B of equal radii have masses m and km respectively. Sphere A is moving with speed u on a smooth horizontal surface when it collides with sphere B, which is at rest. Immediately before the collision, A's directions of motion makes an angle theta with the line of center. The coefficient restitution between the sphere is 1 over 3. Show that the speed of the B after the collision is 4u cos theta divided by 3 multiplied by 1 plus k. Okay, so these questions, we need to build the directions of the speed of a particle before and after. So for before, the particle A is moving with the angle theta at the speed of u. Then for the particle B is at rest. Then after we will assume that the A moving with the speed of VA and in the angle of alpha. But as for the B can only move to these directions. Okay, because B is at rest at the beginning. Then after the collision, B can only move to the direction where they collide. Okay, so this is what you have. Okay, then we can start from considering the directions where they collide. Okay, so you can just start from the horizontal component. So you have PCLM, principle of conservation of linear momentum. We have MU cos theta is equal to the MVA cos alpha plus the KMVB. Cancel the M, you have a VA cos alpha plus the KVB is equal to the U cos theta. Okay, I call this equation number 1. Then considering the Newton experimental law, the NEL, the coefficient of restitution, 1 over 3, is equal to the negative of the VA cos alpha minus the VB divided by the U cos theta minus the 0. So you will have VB minus the VA cos alpha is equal to the 1 over 3U cos theta. That will be your second equations. To find VB, just take the first equations and the second equation, add together. Like this, you can cancel off the VA cos alpha. Then you will have 1 plus the K of the VB is equal to the 4 over 3U cos theta. So from here, you can find that your VB is equal to the 4U cos theta over the 3 multiplied by 1 plus K, shown. Okay, so this is the answer for the part A. Done. Now we move on to the part B. Part B, they are telling you that the total KE, 70% of the total KE of the sphere lost as a result of the collision. That means only 30% remain. Okay, 30% remain. Okay. So what you need to do is that in order to find the KE, you need to have a VA square. You need to have a VB square. So I already have VB at the very beginning. Then I need to square it. But over here, they give you one more information telling you that the tangent theta is a 1/3. So we just make use of this value. Draw a right triangle. 1 here, 3 here. Using the Pythagoras theorem, you get sec 10. So your VB now will become 4u cos theta is 3/10 divided by 3 multiplied by 1 plus k. Cancel the 3, you get a 4u over square root of 10 of 1 plus k. Then your VB square will be the 16u square over the 10 of 1 plus k square. That is your VB. Okay, now we want to find VA square. But the VA square, we not able to find it directly. From the equation number 2, if you go back to equation number 2 over here, these equations, you just need to make, to find the VA cos alpha. VA cos alpha will be the VB minus a 1/3u cos theta. So your VB is a 4u over sec 10, 1 plus k. Your u cos theta is a 3 over sec 10. So if you combine them together, simplify it, you can see that the 3 can be cancelled. Take the u over sec 10 out, then you will get this as the 4 over 1 plus k minus the 1. Combine them together, you get 3 minus k u over the sec 10 of 1 plus k. That will be your VA cos alpha. Then at A, I need to find VA sin alpha. So at A, I consider the vertical component. So the vertical component will be here. This is the vertical component. You can see that the vertical component for A before and after should be the same because it's not involving collision. So you will be having VA sin alpha is equal to the u sin theta. But the sin theta, just now from the triangle, we know that the sin theta is 1 over sec 10. So your VA sin alpha is u over sec 10. Okay, so to find the VA square, the formula will be VA sin alpha square plus the VA cos alpha square. VA sin alpha just like this. VA cos alpha will be like this. 3 minus k u sec 10 1 plus k, the whole thing square. Okay, so you can see that we have the common factor which is the u and sec 10. But if you square it, if you square the u and the sec 10, you can get u square over 10. Okay, so over here, I straight away factorize the u square over 10 out. Here I get a 1 plus the 3 minus k square over the 1 plus k square. Okay, so I just need to expand and simplify. U square over 10, put it here. 1 plus k square, you get a k square plus 2k plus 1 plus 9 minus a 6k plus the k square divided by the 1 plus k square. If you combine the two fractions become 1, then you can see that you will have u square over 10, 2k square minus 4k plus 10 plus k square. I don't plan to expand the denominator. Usually we just leave it first. Okay, so now we have a VA square, we have a VB square. We are ready to find the, to go and calculate the energy. So we have total of the KE loss, 70% of the KE loss. That means your KE final is only 30% of the KE initial. Okay, this is what given in the questions. Oh, not enough, please. KE final will be half M. Oh, not enough, please. Okay, if you don't mind, I will just borrow the space over here to solve it. Okay, so I just take down my VA square. I take down my VA square. VA square is 2k square minus 4k plus 10. Okay, VA square is a u square over 10. 2k square minus a 4k plus 10. 1 plus k square. Then your VB square is 16u square over 10. 16u square over 10. And 1 plus k square. Okay, so our KE final will be half m VA square plus the half km VB square is equal to 30% of half m u square. Okay, so half m cancel first. Okay, so you have the VA square 2k square minus a 4k plus 10 divided by the 1 plus k square plus the 16u square over 10, 1 plus k square is equals to the 3 over 10 u square. Now we cancel the u square. We cancel the 10. Okay, so we will be having 2k square minus a 4k plus 10 plus a 16 equal to the 3 of the k plus 1 square. So if you expand this, you get a 3k square plus a 6k plus 3. At the end, you get a k square. K square. 6k. Oh, sorry. I forgot there's a k here. There's a k here. So this one's supposed to be 16ku square. Cancel the k. You have a 16k here. So if you simplified it, again, you have a k square. And then minus a 6k minus a 7 equal to 0. Factorize it. You have a k minus 7 and k plus 1 equal to 0. Your k equal to 7. Your k equal to -1. We will ignore the negative value for the k. Therefore, your k is a 7. Just like that. That's all. This will be the answer for the question number 6B. Okay, I'll stop the video here. Okay, now we take a look at question number 7. A particle P is projected with the speed u at an angle theta above the horizontal from a point O on the horizontal plane and moves freely under gravity. The horizontal and vertical displacements of P from O at the subsequent time t are denoted by x and y respectively. Use the equations of trajectory in the formula bullet MF90 together with the condition y equal to 0 to establish the range in terms of u, theta, and g. Okay, so we just need to just take the trajectory equations. Trajectory equations. We have a y equal to the x tangent theta minus the gx square over the 2u square cos square theta. This one is from the formula booklet. So when your y is equal to 0, your x is equal to the r, the range. So you have a 0 equal to the r tangent theta minus the g r square 2u square cos square theta. Okay. Your r cannot be 0. So that means you can cancel the r, make it become tangent theta r not equal to 0. This will be a g r 2u square cos square theta. Okay. Then at the end, your r will be equal to the 2u square cos square theta tangent theta over the g. But we know that tangent is a sine over cos. We know tangent is a sine over cos. And if you multiply by cos square theta, this can be cancelled. At the end, you have only cos theta, no square. The square can cancel. So at the end, you can get 2u square cos theta sine theta over g. You can leave the answer like that. But if you are aware that the sine 2 theta is a 2 sine theta cos theta, then we can actually make it become u square sine 2 theta over g. Okay, so you can leave the answer either one. Either one is fine. Okay, so I think we just leave it to. Maybe just depends on the question part B. We decide which one we want to use it. Okay, so now move on. The question mentioned that the maximum height is a h. The maximum height is a h. Then find the h in terms of u and theta. So the maximum height happen at the half of the range. When x is equal to half of the range. Okay, when x equal to half of the range, your y is equal to h. Okay, so again, just use the trajectory equations. Your y is equals to your trajectory equation from the part A just now. Just change the y become h, change the x become half r. Okay, tangent theta minus the g half r square 2u square cos square theta. I'll make it like this. Okay, so your r, change it. I think over here, since this one is theta, this one is theta, no 2 theta, I think it's better we use r equals to the 2 cos theta sine theta u square over g. That will be better. So I make it like this. Half r 2u square cos theta sine theta divided by g tangent theta minus g this one is make it become 1 over 4 r square. R square is 2u square sine theta cos theta square over g divided by the 2u square g. So you can see that this can cancel, and we have the u square sine square theta over g. for this part. Then over here, you can also cancel. Okay, this one, the 2 and the 4 can cancel. And the g square all can cancel. The g square is remain. Okay, this one is no g. 2u cos square theta. This one is cos square theta. Make a mistake. Okay, so this one better don't cancel first. So this one is a cos square theta. So cos square theta later can cancel. Okay, so at the end, you will get this one as the u square sine square theta over the 2g if you simplify them. Then if you minus it, then you get half u square sine square theta. You just get the answer as a u square sine square theta over 2g. Therefore, that is your maximum height. Okay, just like that. Then after that, C, they are telling you that the R is equal to the 4H over Z3. They want you to show that the theta is equals to the 60 degree. Okay, so R is okay, maybe they want R and H. This is the equation 1. This is the equation 2. I call this equation 1, equation 2. So they give you R is equals to the 4H over Z3. Okay. So what you need to do is just to change the R, become 2u square cos theta sin theta. Okay. Make it become 2u square cos theta sin theta over the G equals to the sine square theta over the 3g. That is your h. Okay, so now we cancel the u square, cancel the g, cancel the 2, and we have sine square theta over the cos theta sine theta is equal to 3. That will give you tangent theta equal to 3. Therefore, theta is a 60 degree shown. Just like that for the C. Now, D. It is also given that u equal to Z40. U equal to Z40. By differentiating the equations of the trajectory or otherwise, set the value of x which the directions of motion makes an angle less than 45 degree with the horizontal. Okay, so you just need to take the trajectory equation, you find the dy dx, you get tangent theta. This one is tangent theta minus the gx, the u square cos square theta. Okay, so your u is square root of 40 and your modulus of dy dx is less than tangent 45 degree. That is the meaning of it. Okay, because the directions of the motion, the dy dx is the directions of the angle of the motion. They want it to be less than 45. Less than 45, it can be going up less than 45, also can be going down less than 45. That's why we put modulus of the dy dx less than tangent 45. So this will be tangent theta minus the, I think the g we can make it become 10. The u make it become 4. The u square is a 40. This is a or tangent theta just now. Sorry, tangent theta was theta is a 60 degree. Okay, 60 degree. So this one, I forgot to put in the 60 degree here. So this one is a 3. This one is the cos 30 square. Cos 30 square is cos 60. Cos 60 square is a 1 over 4. Okay, like this, less than a 1. Continue to simplify, you will get this is less than 1. Take away the modulus. That means this is between 1 and -1. So therefore, your x is between 1 plus 3 and square root 3 minus 1. Okay, if you want to make it the same pattern, you can just write square root 3 plus 1 and square root 3 minus 1. So this will be the answer for the questions over here. Okay, and that's all. That will be the last part for these questions. I'll stop the video here. I'll see you next time. Bye-bye.